Project Dojo has been touted by Elon Musk to be a new project that Tesla is embarking on. They've talked about it last year at the Autonomy Day. I want to talk about this because I think it's a lot more important than the market is attributing to, and probably part of the reason why the Tesla stock has done so well in the last couple of days. This is the Not Even Wrong podcast. It's August 19th, 2020. This is Krim Delko. For the day, the fund is up about 2% since the last update on August 17th. The fund is up 10%. For the year, we are up 180%. The S&P is up 5%, so we're outperforming by 175%. Let's jump into the Project Dojo. Musk has been talking about this on Twitter. He's been talking about this at the Autonomy Day last year. Project Dojo is a server-side training technology that is being developed, and the idea is to build a massive supercomputer to analyze video or generally graphic images, but I think primarily video. Why? Of course, Tesla has enormous amounts of video. Now, here's my conjecture. Here's what's going on here, and I just want to put this out there. This is a speculation. I don't have any inside information. I think what Tesla is trying to do is build a transformer that can be used similarly to GPT 1, 2, and 3 in natural language processing. This is what Tesla is trying to do. Tesla is trying to fundamentally re-architect the AI in a sense that they're saying, let's see if we can use the amount of video that we have from the real world and run it through this Dojo computer and in an unsupervised way, and therefore find patterns and correlation that we don't even know about yet now, and use that to then build on top of that our training models. Let me unpack that, because I'm sure, unfortunately, this whole space is full of jargon and acronyms, and you have to be a specialist to understand what's going on. I'm going to try to elaborate in a way that people that are not in the field can understand what's going on. First of all, what are transformers? I'm going to use the case study of natural language processing. So GPT, which is generalized pre-trained transformer, that's what it stands for. GPT is a model that was started by Google and hence has been proliferated by other organizations such as OpenAI. OpenAI just in July released GPT-3. And that is, in a nutshell, think about it this way. What Google did, they ran an algorithm on top of Google Books and Wikipedia. So they just read billions, if not trillions of words. And the algorithm is structured in a way that it captures in an unsupervised way certain patterns and correlations, certain semantics, intelligence, something. You know, I'm really struggling for the right word, but I think maybe the combination of these words gives the sense that there is some sort of intelligence or pattern within language that we can capture just by reading. Now, what is unsupervised versus supervised learning? Just a quick reminder. Supervised learning is the classical machine learning technique where you train a model by saying, this is a cat, this is a dog, this is a car, this is a cat, this is a tree, this is a car. And the model just step by step starts learning by being told right, wrong, and then starts to be able to, let's say, recognize cats. This is supervised learning. I would say most of machine learning, most of data science, most of pretty much anything we do when we talk about AI and machine learning these days is in the realm of supervised learning. Unsupervised learning, as the word says, is when the models learn themselves, so nobody is labeling anything. And the fundamental idea of unsupervised learning is things like clustering, for example. So you look at a bunch of data and you start to find certain order in that data. For example, you look at, you want to do an unsupervised learning model about the weather in the US. You don't teach the model anything, but the model will quickly understand that there's a certain cluster of, let's say, cold weather in the north, warm weather in the south, dry weather in the west. These things will be learned by the model because there is a certain order, there's a certain pattern in the data. You don't have to label. You don't have to tell the model, well, it rains in the Northeast in the winter or something like that. The model will capture those things because there is order. If you give it enough data, this is a volume game. Okay, you need a lot of data to do unsupervised learning. And the idea is kind of like going back. Everything in machine learning is trying to lean on top of our own experience as humans when we learn. So let's say a child is learning in an unsupervised way, right? We're not really telling a 6 months old what to do because they wouldn't even understand what we're talking about. So the child is learning, and in a sort of unsupervised way, figuring out what's going on in the world. Now, of course, some people might say, well, that's not quite true because we also have genetics. We have hard-coded stuff in our genes that make us learn things faster. And I think this is kind of the analogy of a transformer. Okay, let's do the same thing. Let's hard code something. Hard code is maybe the wrong word here, but let's put something ahead of the actual learning model. Let's give the model a sort of a head start by finding these patterns, these orderly things within the data pool. And then on top of that, we can still run, let's say, supervised learning or any traditional machine learning model to then tweak and refine the model. Now, GPT-3 has been a huge success. It's been, some people have been kind of making fun of it. It's been the TikTok of intellectuals on Twitter, meaning because what OpenAI did, they launched GPT-3 and gave an API, which is an application interface, so you can kind of play with it without actually running the model, without training the model. So you can just you have access to the model and you can start playing with it. And what happened is people did things like gave the model a few hints and then let the model develop further text. So for example, you tell the model that fromage means cheese in French, and then let the model translate everything else in French. So what OpenAI in their white paper was talking about particularly is the idea to have one-shot or few-shot learning. So you don't have to keep training the model to the gazoo. You can just give the model a few little hints, tweak the model, and because of the transformer, because of the already pre-trained unsupervised learning that generated all these patterns and orderly things within the data, the model is then very quickly able to transfer the learnings from the unsupervised into the supervised realm or into the actual goal that whatever it is. For example, translate from English to French, or what some people did for fun, write manifest for a spiritual religious cult, things like that. So the model was able to do that with very little pre-existing information, just because the transformers already have that order, that knowledge, that patterns. Those patterns are already there, so you can build on them. And my point is, I think what happened is Elon Musk wants to do the same thing with video. This is the idea of Dojo. The idea is that, listen, if they can do it with text, there's no reason we can't do it with video. And if that works, we could accelerate AI and all these things that Tesla is doing around machine learning and artificial intelligence to the point where maybe we can get to full self-driving much faster, or some sort of full self-driving. And the way I see full self-driving at Tesla is, I'm not too keen or obsessed about the robotaxi stuff, but I can already see now, already me as a Tesla owner using, by the way, not full self-drive, just the autopilot, that it's exactly going in the same direction where the human will be just tweaking the machine, giving the machine a little bit of nudge, a little bit of, it's kind of like a video game where you are still in control, but the machine is doing 90% of the work. I think that's where this is going, and that's already unbelievably powerful. For example, in the autopilot, you can put the machine on autopilot, hold the steering wheel, but the machine keeps the lane, and you're just holding the steering wheel, paying attention, taking over whenever necessary. But slowly but surely, I think that's the idea, that through better learning and better powerful models, and maybe some sort of transformer underlying the model will be able to use those nudges that you as a driver are giving the machine to then very quickly learn, and hence you have to do a lot less of the interventions at the level of autopilot or full self-driving both ways. So this is the idea that the human is there, kind of just like a nudging, like a nudger, like a giving the model, giving the machine a little bit of information, and the machine then very quickly, based on the transformers that it has inside its own algorithm, that based on that it can very quickly figure out what the next right step would be to do. This is a model that has been touted by a lot of machine learning experts. The idea that we are going away from this idea that we hard code that we code everything and then run the model and then recode everything and run the model, and this back and forth, that the machine itself, through having transformers and a sort of elastic algorithm that can rewrite itself or readjust itself to the environment, and therefore the human just becomes sort of the nudger, and the actual algorithms start elastically adapting to the environment, and the human is just the nudger that helps the machine get much quicker to be able to achieve its goals. That's the idea. The same idea is being talked about in natural language processing, where you have nudgers that help the machine basically write its own code and start becoming sort of an elastic machine that adjusts its own algorithm to the environment. And the same idea could be used for a self-driving car, that the machine gets to the point where it adjusts its own algorithms to the environment, and the human is the one actor in this situation that helps the machine through nudging, through acting, through putting the hand on the steering wheel at the right time, at the right place, giving the machine the idea that, okay, now here I have to rewrite or readjust my algorithm because this happened and that happened, etc. So I think that's the idea. And to summarize, what does this all mean? So Musk wants to build a massive supercomputer to channel the video data that Tesla is generating through its fleet into that computer, run it in an unsupervised way, and create a generally pre-trained transformer that then can be used to improve the algorithms on which the Tesla machine is driving itself. And if that works, it's still an open question. Transformers have not been used very successfully in graphics. There has been some attempts, some papers have been written about it. I haven't seen big successes on that front. I think what Musk is thinking is two things. First of all, we don't have the kind of data that is very useful for a full self-driving transformer yet, but Tesla is in the process of generating that data through the increasing fleet of real-world driving. So number one, the data is available. Number two, we don't have a dedicated supercomputer to do that, and that's what Tesla is doing with Dojo. If we combine those two, there's a big chance that we actually would be able to get a GPT for video, and then there is a very high likelihood that we have a nonlinear progress, or like he says, a quantum leap in full self-drive, and that is very, very exciting.